If someone asks you to add the numbers 1 plus 2 plus 3 plus 4 plus all the way to 100, how would you approach it? The average person would end up adding each of those terms individually and eventually getting an answer. But in this video, I talk to you about a trick that's not well known and that can save you hours of pointless calculation. So let's go ahead and get right into the video. Okay, welcome back. Without further ado, let's try and add the numbers 1 plus 2 plus 3 plus ... plus 100 as fast as possible. But to do this, we're going to need a formula. So let's try and prove one for ourselves that we can use on the go. So we have the sum 1 plus 2 plus 3 plus ... plus n minus 1 plus n. And this is for any integer n. So if we plug in 100, we should get 1 plus 2 plus 3 plus ... plus 99 plus 100. So let's just reverse the series. We get n plus n minus 1 plus n minus 2 plus ... plus 2 plus 1. And these two series are exactly the same. The second one is just reversed. So let's just add them. And on the left hand side we just get 2s. But on the right hand side we have something different. We have n plus 1. Then for the next term we have 2 plus n minus 1, which is just n plus 1. Then for the next term we have 3 plus n minus 2, which is just n plus 1. And you can see where this is headed. We have another n plus 1, and another n plus 1. So let's look at how many n plus 1s there really are, as we need to find out how many there are. So in the first series we have 1 plus 2 plus 3 plus ... plus n. So we can therefore conclude, because the series starts with the 1, that there are n terms. So we would write this as 2s equals n times n plus 1, since there are n plus 1s. So we have an expression for 2s, but dividing both sides by 2, we end up getting s is equal to n times n plus 1 over 2. And that's our final expression. See how just using a simple proof we can get an expression like this so easily? So this is a formula you can use easily, as all it is you just have to find n, multiplied by the next term, and divide it by 2. And that's all. So without further ado, let's look at some examples on how to use this formula quickly and efficiently. Okay, so let's look at these examples. So it says evaluate the following series. One thing I forgot to mention in the proof was that when you have something like this, 1 plus 2 plus 3 plus ... plus 100, those are called arithmetic series because they follow a common difference. In this case, the common difference is 1. So 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 100 minus 99 is 1. So that's what an arithmetic series is. And this formula only works for a series with a common difference of 1. So those are some disclaimers I wanted to let you guys know. So let's look at these examples. So we have 1 plus 2 plus 3 plus ... plus 100. The example given in the intro of this video. And that's just equal to 100, which is the last term, times 101, which is the n plus first term, over 2. And that's our answer once we simplify it. For the second expression we have 1 plus 2 plus 3 plus ... plus 1000. And this is just 1000 times 1001 over 2. Now let's look at this last expression. So we have 1 plus 2 plus 3 plus ... plus 121. And this is just equal to 121 times 122 all over 2. So to calculate all of these quickly and efficiently, I recommend you check out my playlist up here on speed multiplication, where I solve speed multiplication problems as fast as possible. So let's look at this first one. This is just merely equal to 50 times 101, which using the 1001 trick, that's just 50, 50. Because 1001 works for 3 digits and 101 works for 2 digits. This next expression we have is 1001 times 1000 all over 2. So we can cancel these out. We get 500 times 1001. And using the 1001 trick, we can just get 500, 500. And that's our answer. And this is our last expression that we have. It's just 121 times 122 all over 2. And this is just 121 times 61. And 121 is actually 11 squared, which means 11 times 11. So we have 11 squared times 61. And then with this, what we can do is we can do 61 times 11 times 11. So we have 671 times 11 now. And that's just equal to 7,381. And that's our answer. So all these problems are easy to do once you know the formula and you can prove the formula. So that's all for today's video. Please be sure to like and subscribe down below, as that helps me out a lot. We have a Math Comp Mondays video releasing every Monday if you want to check that out. And next Friday we'll be elaborating into 1 plus 2 plus 3 plus ... plus n. And we'll start to do some more advanced examples of those problems. So I'll see you next Friday. Bye.